In this video, we're going to discuss fats and lipids. Fats, oils, and lipids are made of long-chain, what we call fatty acids. These could be molecules containing, now each one of these is a carbon that has a large number of hydrogens attached to it. This would be 3 hydrogens, 2 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 hydrogens. And then on the end of this long chain would be a carboxylic acid functionality, similar or the same functionality that we find in amino acids. These long chains of carbons here, whether they have double bonds or they don't have double bonds, tend to be what we call hydrophobic. Hydrophobic means water hating. They don't dissolve, these ends right here, they don't dissolve in water or aqueous media. Whereas this carboxylic acid functionality is very polar, will tend to be water loving. So this bit right here is hydrophilic. These long chain fatty acids are useful for making cell membranes, but generally how we're going to look at them in this video is their use as lipids or energy storage molecules. What ends up happening is that we will have some long chain. So they all have a long chain, long carbon chain that is 5 to 20 carbons long. A saturated fatty acid has no double bonds in this long carbon chain. A mono unsaturated fatty acid has 1 double bond, and a polyunsaturated fatty acid has multiple, usually up to 3, sometimes more, double bonds in that long carbon chain. Now, these multiple bonds are important because every place that there's a double bond, so if we come back and we make double bonds here in our long fatty acid, every place that there's a double bond, that's a more reactive spot on the fatty acid. What that means that the body has the ability to break these carbon chains much more easily at those spots. Consequently, since the way that these are used for energy is that they're converted to carbon dioxide and water, is that every place there's a double bond means that the body can easily change this molecule right at that spot. It's much harder for the body to do that with fatty acids that are unsaturated, like this fatty acid right here. Consequently, monounsaturated and polyunsaturated fatty acids are healthier because they're easier for your body to break down. Now, that being said, because the same thing that allows our body to break down these saturated fatty acids or unsaturated fatty acids, the ones with the double bonds, means that if we have a saturated fatty acid, which means every carbon in the chain is saturated with hydrogens or has as many hydrogens as it can possibly bond to. So if it's bound to 2 carbons, that means it's also going to have 2 hydrogens at every one of these carbons, unless it's the end one, in which case it will have 3. So it's saturated with hydrogens. These are very unreactive. However, if we put a double bond in, now the same thing that allows our body to break this down much more easily means that other things can also break this down more easily. So these mono and polyunsaturated fatty acids are not as shelf stable. And since they're not as shelf stable, they tend to break down, which is why a lot of our fats, if you look in your foods, they are partially hydrogenated, which means that we're actually removing double bonds in our fatty acids that we put in our food so that they're shelf stable for a longer period of time. Most lipids that are encountered in the body are what we call triglycerides. These have a 3-carbon chain that means that links them together here at the carboxylic acid portion of the molecule. And then we will have various different carbon chains that may hang out after. And most of the carbon chains are actually different. So this is called a triglyceride. And most triglycerides have actually 3 different fatty acid chains hanging off of them. Another type of lipid similar to a triglyceride is a phospholipid. A phospholipid is similar to a triglyceride in that it still has long chain fatty acids that are attached to this 3-carbon glycerol backbone. However, one of these spots is replaced with a phosphate group. What makes this useful is that this phosphate group right here, this is very polar. So a phosphate is generally PO4 minus 3. Here we have this charged compound right here. It's still going to have 2 negative charges on here. The third one is gone because now it's bound to this carbon. However, since this is very polar right here, and this is very what we call greasy, so this would resemble an oil right here because it has these long chains. These R groups represent long chains of carbons on the fatty acid. But now we have this polar moiety or functional group, and this will generally manage to, this part will be soluble in water, so it's going to be hydrophilic. These parts right here are going to be very, very nonpolar, especially these R groups, and they're going to be hydrophobic. These make very nice detergents. So phosphates are one of the things that we are very concerned about in the environment because they dissolve fats very well, fats and oils. Here we have this part that dissolves readily in water. These parts that will glob onto the grease on your frying pan or your pot or whatever you had your fatty meal in. And after these help that grease dissolve in the water, they go down the drain.